Go into your calculator and type in, go into the y equals.
What if you possibly forgot batteries once again?
Yes, you get to watch. You can imagine it. All right. So we go y equals. And we're going to go press the y equals button. Did everyone press it? Then we do x squared. So we press the xt theta n button. This one, xt theta n. It's beside alpha.
No, not press alpha.
Don't press alpha. Press the xt theta n button. This should not be the hard part. And then squared. There's a square button here, or you can do this little up arrow, squared. Either one. This one only gets you squared. This one would get you to like 3, to the 4, to the 5, to the 6, whatever. Okay? Now you're going to go zoom. Zoom is the top middle button. And then 6. And the reason why you do that is it'll set your window to the negative 10, 10, negative 10, 10 window. It's a parabola. How'd you know that? He was here. Okay. It's a parabola. It's a quadratic. So what happens is it goes on for life. It makes like one of those U's and it goes on for life, upwards. Correct? Okay. Now we're going to learn some stuff about it. So first off, we're going to draw it off to the side over here. Boom, boom. Okay? How are we going to draw it? We're going to go to our table of values, which actually we'll go to that in a second. We want to find the lowest spot. Do you see there's a low spot? It's called the minimum. It's the minimum that the graph goes to. Do you see that? This here's a minimum. And how do I know it's a minimum? Because if I was actually walking down this little slope here and I was down here, unless I had a shovel, I ain't going any lower. So I'm at a minimum. I'm in a valley. A minimum. We agree? So we want to find the minimum. Now, this is going to be where we're going to go for most of our life in grade 11 and 12. When we want to calculate something, because I want to find that minimum, correct? I want to calculate something. I'm going to go second, the second button, and then I'm going to go trace. I'm going to put down the marker first, actually. I'm going to go second, and then I'm going to go trace. Because what's the word above trace? Oh, I have one that actually isn't good. There you go. This one's totally good. Okay. So I'm going to go second, trace, because above trace is calc. And second gets me to all the little words above, correct? And I want to calculate something. So I'm going to go second, trace, so I calculate. Which one am I going to calculate? 3, the minimum. Now what we're going to find out is this is actually called our minimum and our maximum are called our vertex. Okay? So there's no second calc vertex because there's no vertex word up there, is there? But I'm going to find the mins and the maxes, which are the vertex. Okay? So I'm going to go second trace min. Then my calculator tells me stuff. It says, I want left bound. Left bound means left bound of whatever the heck you're finding. And what did we choose to find? What did we pick? The minimum, correct? So we want to find this. We want to find the minimum. So I need to be on the left of it. Correct? Right now it's blinking underneath there. So I need to be on the left side of it. So I need to be somewhere on the left. I could be here, 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 all the way up here. I could be here. Any of these. I could be just so on the left. I wouldn't go like 80 above because there's no point. So I just go a little bit on the left. And then it says left bound. Then I hit enter. Now what does it say? It says right bound. So now I need to be on the right of whatever I'm trying to find. I'm trying to find this black dot here, right? So now I need to be on the right side of that. Okay, somewhere over here. Hit enter. And then when it says guess, it's not like you just randomly guess. I don't know why it does the guess. It's the way the functions work. You just hit enter again. Now, this throws people off. To me, this minimum looks like it's at 0, 0. That's where it looks like it is, right? But my calculator says 1.0674 e to the negative 6 and 1.139 e to the negative 12. That's just scientific notation, correct? So for x here, that just means there's 5 zeros in front of this 1. And for y, there are 11 zeros in front of this 1. So what are they just? They're just 0, 0. So whenever you get this, always look at the back. If you have e to the negative anything, that just means this is 0 and this is 0. Because this is really just 0 decimal 1, 2, 3, 4, 5. Oop, I went off the thing. So this is just this, right? Which we can round to 0. We agree? So whenever we have these e to the negative anythings, that's just scientific notation for 0. So I know then that my minimum is at 0, 0. So I'm going to go back here, and I'm going to go to my minimum, and I'm going to put a 0, 0. Now I also have to decide what my scales are going to be. My x scale and y scale. And what does that mean? It means what each tick is worth. And you did this in science all the time. You have to decide what each tick is worth. You've done it in math before. So I'm going to make my x scale be 1. But because this is 1, 2, 3, 4, 5, 6, 7 only, up, I'm going to make my y scale be 2. And you'll see why when we make the... So if I write y scale of 2, then this is 2, 4, 6, 8, 10, 12, right? 14 now. This is still 1, 2, 3, 4, 5. So I'm not changing the x scale at all. I'm just changing the y. Do we see that? Okay. Okay. So I know that I'm at 0, 0. Then I go back to my calculator. Now I want to get more values off this calculator. We agree? So I'm going to go second graph. And it gives me a table of values. You know, remember those t-tables, the XY t-tables you made in grade 10? This just gives them to you. So you're going to go, but it's all in integers. So we go second table. Now, I can arrow up and I can arrow down. Now, what I want you to do is not arrow up and down for life. It will just keep going, and you're going to have to hold the button down equally as long as how long you held it down to see how long it goes. People will hold the list. There's always someone who holds the list for like 20 years and tries to see how high this will go till. You're going to have to hold it equally as long to get it to go back down. So stop. Stay where we are. Don't go up and down for life. Okay? So we have 0, 0 on here. Now, are we always going to have our mins and maxes appear on this chart, on this table? Are there any decimals for x's on here? No. So if our min or our max is not like an integer, it's not going to appear on here. So we're going to have to find our mins and maxes using the functions that we just did, right? But we can pull all of our integers off of here. So we have 0, 0, and then I'm going to pull some from above and some from below. So negative 1, negative 1 and 1 I'm going to plot. Negative 1 and 1. Then I'm going to go up here, negative 2 and 4. That is not negative 1 and 1, by the way. I made a y scale of 2. Why did I put it there? Negative 1 and 1 is here. Negative 2 and 4 is here. We have to remember that we changed our y scale to 2. Are you pressing the up and down arrow for how long it goes?
I was just trying to figure it out.
Okay.
It's just messages.
Okay. That was one. All right. And then negative 3 and 9. So negative 3 and 2, 4, 6, 8, 9. And then that's all that fits on here. And it curves. It's not a point down here. It's always a curve at the bottom. It's not like a valley. It's not a steep valley or a steep mountain. It's a curving thing, parabolas. Okay? Now what's great about them is they're symmetrical. So what you see on the left, you're going to see on the right. So if I go back to my graph, I have 1, 1, 2, 4, 3, 9. I have to plot those as well. 1, 1, 2, 4. Why did I just plot it again though? 1, 1, 2, 4, 3, 9. And we have the graph that's on your calculator, right? Do you understand how we found that? Everyone understand that? Okay. So, what is the vertex on this one? Well, the vertex, we're going to write this down and we're going to highlight it if we think we're not going to remember it, which a lot of people don't. It's the maximum or minimum value. It's the whole maximum or minimum. So it's that coordinate that's the lowest or the highest, correct? And in this case, it's a what? It's a minimum. And it's at? Pardon? Yeah, 0, 0. What's the direction of the opening? Up or down? Is it open up or open down? Up. So we call this concave up. The range are the y values and the domain are the x values. And the way I remember it, range, if you draw a line through it, it has a little thing. Y, if you draw a line under it, has a little tail. X, domain, no tail. See that? Look at that. Draw a line, one has a tail. So range and y go together. Domain and x go together. So our range, we're talking about the y values. Can you tell me what y values exist on this graph if you look at it? Yeah.
0 and greater than 0.
Yeah, or, and, yeah, 0 and then greater than 0, so we say equal to, right? So there are no y's below 0, are there? Are there any negative y's on this graph? So this graph starts at 0, and it's equal to 0 because we have a closed dot on 0, correct? And greater. So how we write that is we go squiggly bracket, and the squiggly bracket means the set of. If you stink at squiggly brackets, you still need to attempt a squiggly bracket, because if it's a square bracket or a round bracket, it means totally different things. The squiggly bracket means the set of. It's literally just a forwards S and then a backwards S. At least try that out. Forwards S, backwards S. And then the back one's going to be a backwards S, forwards S. If you just do this, I'll accept it. Let's try. Okay? So we're going to go the set of. Both of them would start with that. The set of. Both of them are going to start with squiggly bracket. But range is what values? What did we just say? Y's, right? So we're going to say the set of y values, because we have to say that it's a y, such that it's a straight up and down line, even though it doesn't look like it because my board is making it curve. It's a wonky spot. So it's straight up and down line. Y such that, now what did you say y is what? Greater than or equal to 0. So far we have the squiggly brackets, which mean the set of. And if people are like, do I have to write them in this format? Yes, you do. Grade 12, they'll be asked in this format as well. The set of y values such that y is greater than 0. Now what you have to do is you follow behind with, okay, y is greater than 0, but what number set does it fit in? So if y is greater than 0 and y is an element of the integers, I would only have dots at 0, 1, 2, 3, 4, right? But no connecting. Are they connected? Yes, so it's not integers, it's not whole numbers, it's not natural numbers. When all of the values are connected and I can have every single value in the number system, remember what number system it is? Starts with an R. It's the reals. The real numbers. The real numbers contain all the integers, all the rationals, all the irrationals, or all the rationals, sorry, all the reals, all the whole numbers, all the naturals, everything. So when you can connect them all, we always follow behind with a semicolon. Y is an element of the real numbers. Now you can do a single R like this, or you can do a double lined R. It means the same thing. In university, they'll always do a double lined R, so they just basically it looks like this. It's an R with a line. I always just do 2 lines and then draw an R, is how I did it in university. But if you do it as just an R, they'll accept it. So there are no y values below 0, correct? 0 and above. That's what that's saying. Now we have to look at the x values for the domain. The easiest way to determine the domain and range is to figure out where the heck the graph doesn't exist. So I knew for range, the graph doesn't exist anywhere in the negatives. So it's 0 and above, right? So that was not so hard. X's. Are there any x values that don't exist on this graph? We start at 0 on the x, and then we go to -1, -2, -3, all the way this way, correct? We start at 0 on the x, and then we do +1, +2, +3, and then we praise Jesus. So, is there any x's on here that don't exist? No. So if you can go like this with the graph, both up, or you can go like this, like you're a tough guy, bulking up, you know what I'm saying? All the x's exist. So if it's either up like this or down like this, all the x's exist. I just popped something doing that. Yeah. You know you're old. Okay. That means every x value exists. So when every x value exists, we say the set of, that's what the squiggly bracket means, x values, such that x is an element of the what meant everything exists? Which number system? The reals. And that's it. We don't have to actually specify greater than or less than or equal to or anything like that because it's just everything. So we go right to the real number system. And then we'll do the axis of symmetry. We won't deal with the x-intercepts and y-intercepts for now. We're just going to deal with the top 4. The axis of symmetry. Do you remember making hearts in like younger years? When you make a heart, you'd fold the paper in half, and if you cut around half the heart, you'd have a full heart. And it would actually be symmetrical. Well, you missed out. I will give you paper later. You can make yourself a heart. Okay. So that line, that when you unfold the heart, that line is called the axis of symmetry. Okay? So it's going to be a vertical line. So this graph has a vertical line cutting it in half right here. This is called the axis of symmetry. It's the axis that if I folded it on it, I would get myself the same thing on both sides. Okay? Now what you need to know is vertical lines are always x equals lines because they're cutting through the x-axis, correct? And horizontal lines, straight up horizontal lines, are always y equals lines. Okay? So is this going to be an x equals line or a y equals line? It's an x equals line because it's vertical. So I know that the y-axis runs up and down, that's great, but all the lines that run up and down are x equals lines. And what's it cutting through? What x? Pardon?
0.
0. So the axis of symmetry for this one is x equals 0. Your axis of symmetry, I'm going to write this down here, is always the x of the vertex. The x of the vertex. And it has to be an equation. So you have to go x equals. So if your vertex was at like 2, 4, it would be x equals 2. If your vertex was at -7, 6, it would be at x equals -7. It's whatever the x is of the vertex, because it's always what cuts it in half. The x of the vertex. Does that make sense? All right. So what I'm going to get you to do is we're going to actually just sketch the original back on here again. It's at 0, 0. I'm going to do a y scale of 2 again. And then x scale of 1. So we have 0, 0. Oh, I did it again. Adapt, Crystal. Adapt. Okay. 1 and -1 and 1. 2 and 4. -2 and 4. And 3 and 9. 4. 3. And then we're going to label it because we're going to actually draw 3 graphs on here. So I'm going to label this one f of x equals x squared. So that's just your basic function again. I'm just redrawing it. And if you look here, the vertex is 0, 0. It's up. The range is y, which I would rather have y such that y is greater than or equal to 0, yer. and my domain is x such that x is an element of the reals. So you can do like plain R, or you can do double R, it doesn't matter. And then the axis of symmetry for that one was x equals 0. So we're just copying down what was above, correct? Now I want you to type into your calculator. So go to your y equals, clear it out, and type in 2x squared. Then press graph. Now what I'm going to do, and I'm going to take this back off in a second, but I want you to do this. Go to your y2 and type in x squared so you can actually see what's going to happen. So we're going to type in x squared, but pay attention, don't press graph yet. So we're going to go x squared. If you have the calculator that has colors, great. If you have not the calculator that doesn't have colors, so you're going to see most of you do not have one with calculator with colors, what you're going to do is, if you press graph right now, it's going to draw just two graphs looking the exact same, like the lines are the same, correct? It will always draw them in order. Just pay attention. Don't do this. So if I press graph, it'll draw them in order. It'll draw the 2x squared, then it'll draw the x squared, correct? But both of yours are the same thickness, and both of them are the same color, correct? So press graph. Right? Okay, now you go and you go do some work, and then you come back and you're like, uh-oh, which one is which? You don't know. Which one represents the 2x squared and which one represents the x squared? It's confusing, isn't it? I can tell, because the blue is the 2x squared and the red is the x squared, correct? But you don't have the colors. So there is a way, we can only do this with 2. So you're going to go back to your y equals and you're going to go to your x squared. I always do it with my x squared. And I arrow to the left till you're on a slanted line. Yours just doesn't have a color beside it, just has a slash line. You see that? Okay, you're going to hit enter once. Right, Xander? You're going to hit enter once. Go get a drink of water. So you're going to hit enter once. Did everyone do it? And you see a thick line. Now, if you hit enter a whole bunch of times, it's just going to change to other things that are not helpful to you. Okay? So you just go back, it'll circle back to it. So if you hit enter, it'll go back to the thicker one. Okay? So you just want to hit enter once. You don't want to hit it 700 times. You don't want to check out what the rest do. Some of them draw, some of them shade. Some of them draw a little thing. It doesn't matter. We just want the thicker one. Okay? Now you know, because you made the second one the thicker one, press graph. So I always make the second one. I always make my y2 be the thicker one, because then I'm being consistent. So if I go, you can make your y1 or your y2 be thicker. I always choose my y2 to be thicker, because then I know always the second equation I'm typing in will always be the thicker one. Now I go do some work and I come back and I know which one's which. Does it make more sense? Yes. Do you see it? So you go over to your y2 and you arrow to the left to this slashed line. And you hit enter once. Now press graph. Go over, there's a slashed line as well. Yeah, well, arrow left. I believe in you. Okay, yeah, you hit it 20 times. So that's the normal line. You just hit once. And it's like press graph. So now you see the difference between y1 and y2. We agree? Okay. What happened when I put a 2 in front? What happened when I don't know why I just got out of it. What happened when I put a 2 in front? It gets steeper. It actually narrows, correct? Because what it's actually doing is it's taking your y values and it's multiplying them by 2. So now instead of it being at 1, 1, it's at 1, 2. And instead of being at 2, 4, it's at 2, 8. So it's making it climb faster. Okay? So we're going to clear out the y. If you just watch, don't do this yet. If I go second table, it's going to give me table values for both. So this x stays the same, but it gives me the y's for the first one or the y's for the second one. It's slightly confusing. So what I'm going to do is I'm going to just take out my x squared. That's why I put it second. I'm going to press clear. And now I'm going to press graph, and now I just have the 1. So I go second graph. Now I can pull values off of it. So it's still at 0, 0. It didn't change that spot, correct? Why didn't it change the 0, 0? Because I'm multiplying my y's by 2. And what is my y at 0, 0? 0. And when I multiply it by 2, it stays 0, so it's not changing. So we're going to go 0, 0, negative 1, 2. We're going to use this to sketch our other one on here. So we go 0, 0. I'm going to use 0, 0, negative 1, 2, negative 2 and 8. And then this one goes off, so I can't actually draw it anymore. This one's 1 and 2, 2 and 4, or 2 and 4 is what it was. It's 2 and 8 now. And then we just sketch. And then I have to label it. Y, or F of it. I zoomed again. F of x equals 2x squared. Okay, you're going to help me with the vertex of this one. What's the vertex of the blue one? Did it change? What is it? It's the min or the max, correct? So it's 0, 0. It's a minimum at 0, 0. Is it concave up or concave down? Yeah, it's still up. Did my range change? Graph starts at 0 and it goes upwards. So it's still y such that y is greater than or equal to 0, yer. It's going up like this. So what's my domain? Yeah. So it's a set of x values such that if it goes up or down, which means every quadratic, your domain's always going to be xer unless it's a word problem. So domain isn't going to change for both of these next two units. It's going to be x such that x and l are the reals. But my range will change. My domain won't. What's my axis of symmetry? What's the line that cuts the graph in half on this one? Yeah, it's the x of the vertex always, right? X of the vertex. Did my vertex change? No, so my axis of symmetry isn't going to change. X equals 0. Now I want you to type in, so go to your y equals, clear it out, and I want you to put in 1/2 x squared. If you have the older calculators, how does it know that you have a fraction? Brackets. So 1/2 x squared, put it in brackets. If you use the alpha y equals enter button and you use 1/2, it'll just give you your answers in your table in fractions, and sometimes that's hard because I don't know what 7/5 is as a decimal. Okay, so we're going to go graph. Oh, I'm going to go to my x, I'm going to put x squared in my y2 just to see what's going to happen. And I'm going to press graph. You guys might want to make yours thicker. So the blue one is the half, and the red one is the x squared. What happened now when we got a fraction in front? It actually got wider because my y values are being multiplied by a half. When you multiply 2 by a half, you actually get 1. So it's going to cause the graph to, all the y values to drop. Instead of rise fast, they're going to drop, drop, drop. So it's going to actually make it wider. Okay? So how do we get our table of values? We go to second, graph. Oh, sorry, I'm going to clear up my x squared. Second, graph. And you're going to go here and you're going to plot your graph. So everyone try that out. I'm going to let you plot it. So we should have 0, 0 again. And now we're going to have -1 and 0.5, so that's halfway down. And then we have 2 and 2, so it's 2 and 1. And then it's going to be 3 and 4.5. and then 4 and 4. Wait, that's not true. 4 and 8. And then this one's going to be 1 and 0.5. So I'm just pulling these off the table of values. 1 and 2, 2 and 4.5, and then 4 and 8. And this one is f of x equals 1/2 x squared. So it literally just made it wider. That's it. Correct? So does that change my min or my max? No. Does it change my axis of symmetry? No. Does it change my vertex? No. Does it change my range? No. My domain? No. Just makes it wider. So all these are going to stay the same. 0, 0. Concave up. Y such that y is greater than or equal to 0, YER. X such that x now with the reals. And all of these, every single one of them, I mean, color yellow, has an axis of symmetry here. Every single one of them cuts in half here, which is x equals 0. Okay, then we're going to flip over. So when we just add that a in front, if the a is greater than 1, the graph got what? If your a was greater than 1, like the 2, what happened to the graph? It got skinnier. And then if our a value is between 0 and 1, like a fraction, like a half or 3/4 or whatever, it's going to get wider. So that's that a value in front. So this here. Actually, go back to a page. We'll summarize it up there. That's fine. Go back to this part. We're going to say if a is greater than 1, the graph gets narrower. And between 0 and 1, it gets wider. Okay. And you're going to flip over. So now in your y equals, you're going to type in negative x squared.
Oh no.
And not subtraction, negative. Negative's beside the enter button. Negative x squared. We don't say subtraction x squared, we say negative x squared. Yeah, it's going to bulk up. That's what it's going to do. Get all bulky. There it is. Yeah. What do you think if we put a fraction in front of it? It's going to get bulkier. And then what's going to happen if we put a number greater than 1 in front of it? It's going to become a skinny boy. Yeah. Or girl. Human. Okay, so if we have a negative, the negative causes the graph to be down, correct? That's all the negative does. The negative causes it to be down. The number in front of it causes it to be wider or narrower, correct? But the negative just causes it to go down. So this is just negative x squared. It's actually the exact same as the x squared. It's a reflection in the x-axis. So if I put my x squared here, it's just reflecting it in the x-axis. It's going from here to here. It's making every y value that's positive now be negative. That's all that's happening. So if I take this out and I want to find the vertex, what are you going to have to calculate? Remember, finding the vertex is finding the max or the min, correct? In this case, what are we looking for? The maximum. So how do we find that? We're going to go second trace And then what? You are right, but we're going to practice anyways. Second trace?
6.
No.
4.
4.
I said 6.
I don't know. Now, we need to be on the left side of the vertex. So the vertex is this right here, correct? We need to be on left bound, it says. So I need to be on left bound of the maximum. So enter. Then right bound of the maximum. So enter, and then enter. So what did it give me? Something e to the negative 8, something e to the negative 15. What are both of those? 0. So it's 0, 0. Okay, let's sketch it out. So if we go, now you're going to go second graph. I'm going to keep my y scale at 2 and my x scale at 1. Oops. So start plotting your stuff on there. Go second graph and plot your dots. We have 0, 0, and then we have 1 and negative 2, negative 1, negative 2, 2 and negative 4, and negative 2, negative 4, and then negative 3 and 9. 2, 4, 6, 8. Oh, goodness, I did the 1 thing again, guys. Like, I'm not adapting. I'm not adapting to the Y scale here. I made it myself and still not adapting. Okay. Okay. All right. So, put it away. You're always so good in my class. Don't be bad. No, I would just not put it there. You know what? If you put it there, what's going to happen? You're going to touch it. Put it away. All right. What is the vertex at? 0, 0. What is it concave up or concave down? Why? Because your A is negative. Exactly. Concave down. What's my range this time now, though? Yeah, less than or equal to. And it's still at 0, though, right? Because we're still equal to that 0, but now the whole graph's below. So my range is going to be squiggly bracket, which means the set of y values such that y is less than or equal to 0. Y is an element of the reals. Now I'm bulking up. What's my domain? Same thing, just XCR. So whether we're up or we're down, unless it's a word problem, all quadratics are going to be XCR. Because all the x's exist. If you go this way or you go this way, they're going to go up for life, right? So it's going to be x such that x is an element of the reals. What about x equals 0? Is it going to be the same? Yeah, my axis of symmetry still cutting through the y-axis, which is the equation of the y-axis is actually x equals 0. I want you guys to type in y equals, or f of x equals negative 2x squared into your calculator. I need to label this one. F of x equals negative x squared. Okay, I want you to type in negative 2x squared and draw it. What do you suspect is going to happen? It's going to be what? It's going to be narrower, so steeper, and it's going to be concave down. So the 2 is going to make it narrower, and the negative is going to make it go down. Correct? So everyone type it into your calculator, and if we go to sketch this one, we're going to still be at 0, 0. Then we're going to be at negative 1, negative 2, positive 1, negative 2, and then negative 2 and 8, negative 8, positive 2 and 8. So it's still concave down, And it's concave down because of this. So I'm going to write this here. I'm going to say concave down. So the negative makes it down. The negative doesn't make it wider or narrower or anything, correct? The negative just causes all my y's that are positive to be negative, to be down. So positives to be negative. So the negative makes it concave down. The 2 makes it what? Yeah, skinnier, narrower. So what's my vertex at? Same, 0, 0. It's concave down. Does anything else change? Does anything else change? The graph is y is less than or equal to 0, it's xer, and x equals 0. So it just made it narrower and down, right? But it didn't, narrower or wider doesn't change any of the things that I'm talking about. So it's going to be y such that y is less than or equal to 0. Yer, x such that x is an element of the reals, x equals 0. So we're just going to talk about the first two because the last two kind of confuse people. So we're just going to talk about these first two. If a is greater than 0, which means a is positive, so this is in the form like this. A is greater than 0, so positive. What happens to the graph? It's concave up. And if a is less than 0 or negative, it's concave down. You got it. We already talked about the other things, the other two parts we talked about on the previous page. If a is greater than 1, it's narrower, right? If a is between 0 and 1, it's wider, which we wrote on the previous page, so we don't really have to talk about that as much here. Okay. So what happens if I add a cube at the back? What happens if I have an x squared and I add a cube? If I add a number to the back of it. So all we've done so far is added numbers to the very front in that A position, right? We haven't added numbers to the back. So let's look at this. So once again, I want you to go y equals, now I want you to go x squared plus 4. So you're typing this into your calculator right now. Y equals x squared plus 4. And in my y2, I'm going to put my x squared, just my generic one, just so we can compare them. So in my y1, I have x squared plus 4. And in my y2, I'm just going to put x squared so I can compare them. And I'm going to press graph. So the red one is the original. What happened? Went up. How many? 4. What was the number at the back? 4. Coincidence? I think not. Coincidence? I think not. So I'm going to go to my y2. I'm going to clear up my x squared. And I'm going to graph this. So I'm going to go second graph. So it's at 0, 4. Let's find it first, actually. Sorry. I want you to find the vertex. How do we find the vertex? We don't want to assume that it's 0, 4. It is, but we don't want to assume that. How can we find it? We can't go second trace vertex because there's no option.
Minimum.
Second trace minimum is the option we have to pick. So we go second trace minimum, which is number 3. Now we need to be on the left side of it. Enter. Right side of it. Enter. Enter. Did you do your lefts and rights properly? Yeah, if you do them opposite, it'll error you. So this is 1.858. People will tell me it's 1.8. Does that look like 1.8? No. It's got an e to the negative 6. So what does that mean? It's very, very small, which means it's actually equal to 0. I know you were talking to yourself, but you answered right at the right time, but it's not the right answer. But right for you. Okay. Actually, it was left for you. So it's at 0, 4 is our vertex, so it has moved. I don't want crayons. So it's at 0, 4. And it's up. Why is it up? Because my A is positive. The number in front of here is a positive 1, correct? If it's positive in front of here, it's concave up. So this 4 at the back changes nothing other than moving the graph 4 up. So everything where it was is now going to be 4 above where it was. So I can sketch it from the original if I want to. So I'm going to go Y scale 2, X scale 1. And I'm going to draw my original on here. My original is 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and then 3, 9, 2, 4. So this is the original. Oops. Now you can use your table of values, correct? If you go second graph now, it'll give you a table of values. We agree? Or what we're really doing is we're just moving this green graph 4 up. So we're literally taking every coordinate and just moving it 4 up. So you can either use the original and move it 4 up, or you can go right to your table of values and do it. So this one's going to be 4 up. This one's going to be 4 up. 4. 4. It's going to be 4 up. 4 up. 4 up. Or you can just plot the points off the table of values, right? They're on your table of values. I just literally just moved this graph 4 up. But if you go second table, it gives you all the coordinates. We agree? And I'm going to label this one as f of x. Is my range still greater than or equal to 0? No, what's my lowest y value now? 4. Is it equal to it? Yeah, I have a closed dot on there. And then it's what? Greater, because the arms are going up. So we're going to do y such that y is greater than or equal to 4. Y-E-R. Now it's still going, hallelujah. And when it does that, what do we get for domain? We get Jesus, which is real. X and L are the reals. Connection, I think so. Okay. X such that X and L are the reals. Has my symmetry moved?
Yes.
No, it's still, what's still cutting this in half? The y-axis, right? And if the y-axis is still cutting it in half, it's x equals 0. It's also always x to the vertex. And what's my vertex is x? 0. So if you have your vertex, you have your axis of symmetry. It's the x of the vertex. What do you think this one's going to have happen? What do you think is going to happen to that one? To move 3 to the down. I don't know why I would say to the. 3 to the down. Yes. Solidly moving 3 to the down. So I don't even need to type this one in. I just need to move the green one 3 to the down. So I'm going to do that. 1, 2, 3. 1, 2, 3. 1, 2, 3. 2, 3. 1, 2, 3. 1, 2, 3. Pretend that's straight. Why is the graph still up? I moved it down. Why is it still concave up? because the x squared is still positive. That didn't change, right? I just moved the graph 3 down. So, what's my vertex at now? 0, comma, -3. It's still concave up. My range is going to be y such that y is greater than or equal to -3. And then x such that x none of the reals. What's my axis of symmetry? X equals 0. So our summary here, if q is greater than 0, if this q is greater than 0, what's happening? The graph is moving. What? Moving up. I see some people pointing. And if q is less than 0, which means this is positive, that's how they rate positive, and this is how they rate negative. If q is less than 0, it's moving down. But my graph is still concave up because the x squared is what tells what's concave, right? We have one more to go over. What's great about this is a learning day, not a homework day. Okay. So what happens if it joins the x? So now it's joining the x in with the squared. We agree? So we call it the p. So I want you to now type in x minus 2 squared.
With the brackets.
Yep. You have to put it in brackets or it's not with the x. So we're going to go bracket x minus, not negative, x minus 2 squared. And then this one I'm going to put x squared just so we can compare them. Where'd it go? She went where? Over 2 to the what? To the right. Wait, it was x minus 2. It moved 2 to the right. Didn't it? Yeah. Okay. Cool. Let's try it. Let's put it down. It's going to move opposite. If you look here, this has an x minus p in it, correct? It was a plus q at the back. So the q just did whatever it was. If it was positive, it goes up. If it was negative, it goes down, correct? This one actually has a minus sign in it. So if I have the equation y equals x minus 2 squared, it's x minus p squared. The p actually matches up with not the minus 2. The p actually just matches up with the 2, doesn't it? You see that? So that's why it moves to the right and not the left, which you would think it does because it's minus. The equation has a minus sign in it. P is what actually is what movement does. So p matches to positive 2. So if it's x minus 2, it's going to move 2 to the right. What do you think is going to happen when we have x plus 1? 1 to the left. Yeah, exactly. So let's sketch this one out first. So I'm going to sketch the original. So we have a y scale of 2. We have an x scale of 1. We're at 0, 0. So I'm just plotting the original. Now, could I not just type x minus 2 squared and then just go second graph and plot it that way? Can I do that? Yeah. And not plot the original at all? Sure. You could go second graph right now. So do that. Go second graph and plot this graph that you have in front of you. So I know the vertex is at 2, 0 because it moved 2 to the right. So I would start there and then work on both sides. So try that out.
Yep. No problem.
What's the vertex of the red one? What's the vertex of x minus 2 squared? 2, 0, yeah. And the graph is still concave up because there's still a plus in front of here, correct? What's my range? What's my lowest y? 0 is still the x-axis, right? Even though it shifted to the right, it's still 0, so it's going to be y such that y is greater than or equal to 0, yer. Still saying hallelujah, I'm just 2 to the right saying hallelujah. So what's my domain? X and L is reals, yeah. What's my axis of symmetry? 2. But we don't just say 2, we say x equals 2. Because my axis of symmetry has moved. It's the x of the vertex, right? My goodness. Great. So it's here. Which is x equals 2. Sketch this one, please. Fill in the chart. Let's sketch this one. So now it's 1 to the... Which way are we going now? If it's x plus 1, that's the same as going x minus a minus 1 squared. Remember, we need a minus sign in here. So that's why it's actually 1 to the left, because it's minus a minus. Whereas the 2 is just positive 2. This one would have to be x minus minus. So it's 1 to the left. So I'm going to be here, and here, and here, and here. So, what's my vertex at? What's my vertex at? -1 and 0. It's still concave up because there's a plus 1 in front. My range is still y such that y is greater than or equal to 0. I'm still saying hallelujah. So it's x such that x and L are the reals. And my axis of symmetry this time is x equals what? Amelia Wade's just dancing it out over there. X equals what? -1. So let's look here and say what happens. So if we have an x minus p, where are we actually moving? P to the right. And if we have an x plus p, we're actually moving p to the left. P to the left. We're going to do a little summary down here, and then we're done for today. Then we're going to put it all together tomorrow. So what does the A tell me? What does this A value give me? If A is greater than 0, which means it's positive, what happens? It's concave up. Yep, concave up. If A is less than 0, so negative, it's concave what? Down. If A is greater than 1, technically we can also say if A is less than -1. Why would we say that? Less than -1 is like -2, -3, -4. Does the negative actually do anything? Does the negative do anything to making it wider or narrower? No. It's actually just the number. So if A is greater than 1, the graph is what? Narrower, right? If it's between 0 and 1, or technically 0 and -1, it's wider. I'm just going to leave it as this because it gets confusing when you add the negatives. What does the P do? What does the P do? It moves it left or the right. So if I have x minus p squared, it's going to move it what? Move p to p units right. Yeah. If I have x plus p squared, it's going to move p units left. What does the q do? The q moves it up or down. So if it's a positive q, it moves q units up. And if it's a negative q, it moves q units down. It's called a horizontal or a vertical translation, but we're talking about translations and stuff later.